All right. Good evening, everyone. My name is Wale. I'm an engineer here at Global Logic. So I'm going to first of all talk to you about fire exits. Fire exits are behind the kitchen, and in case of an emergency, we're gonna meet up downstairs in front of Goucher. And in regards to toilets, they are by the lifts. So it's at the end, the door on your right, basically. Those are the toilets. What else? What else? What else? Just give me a second. Toilets, fire exits. Oh, and pizza. Pizza will be after the presentation as to why we're here, and after the lab as well. And in regards to Wi-Fi, if you didn't get a chance to grab the Wi-Fi while it was here, we have papers that I can hand around to you for you to get the Wi-Fi access, basically. So don't worry about that. During the labs, if you do need any help, please don't be shy. Raise your hand. One of us will be able to help you, either myself or Grace, right? Yeah, Grace. And then we also have some people at the back as well that can also help you. So there's plenty of us. Yeah, so I'm going to pass it on to the reason we're all here, Matt Selman. He's going to talk to you about Playwright and Cucumber. Yeah, so on to you.
Cool. Thank you, Wale. Hello, everyone. So today we're going to go through Playwright and Cucumber. We're going to go through a presentation first, then we're going to go through a lab, and then after that we'll have some pizza. So slide there. And this is part of the DevOps playground provided by Global Logic. So a little bit about me. My name is Matt Selman. I've been with Global Logic for 6 years now. My experience is mainly in testing and DevOps, and that's been working just to enable engineering teams, facilitate successful deliveries, and teaching others. My industry experience is mostly with the energy, finance, and technology sectors. And this is all alongside my favorite hobby, which is annoying my co-workers. So the objectives of today's presentation will be an introduction to UI automation, as well as its benefits, introducing Playwright, Cucumber, and TypeScript, and introducing user journeys, the page object model, and some best practices, as well as a lab afterwards. And then after the lab, we'll have some pizza, and there are drinks there as well. So, what is UI automation? So automated web testing refers to the usage of frameworks to automate manual test processes that verify UI functionality. UI functionality is, in this case, user interfaces. It's also called GUI, as you can see on the top of that testing pyramid there. That's just graphical user interfaces, the same thing. So the UI automation, it allows the validation for things like logins, UI workflows, navigation, and other web page interactions, which can be automated. Sometimes you can't automate things, and there's nothing you can do about that except manual testing. But that certainly does have its place. This isn't necessarily restricted to websites, but can also be with applications. And do note that this is specific to UI functionality. This also allows for greater efficiency, mainly in the minimization of time and human effort involved to confirm good working order in new functionality and just to prevent regression in old functionality. So why use UI automation? So UI automation, the tests are easily scalable. Much like infrastructure as code that you'd find in DevOps, you can write something once and then use it over and over again elsewhere. In a way, this also acts like a living documentation and allows you to reduce any tech debt you might have. UI tests are generally faster than manual testing, and in many cases, they're faster than humans can be. This is also immensely helpful for repetitive tasks, such as web scraping, data gathering, and data input. Sorry, it's too early. Automated tests are also not prone to human error. Where a human might get tired and make a mistake, automated tests will not do that. They'll just do the same thing every time in exactly the way you programmed them to do. And this leads directly to faster feedback, which makes it easier to see if anything has gone wrong and where it may have gone wrong. This also is incredibly helpful for root cause analysis. So, Playwright. So the key features is Playwright is a Node.js library, and it's used to automate Chrome, Firefox, and WebKit browsers within a single API. It acts as the test reporter, test runner, and the library itself. This makes installation and integration with other services much easier. For reference, something like Selenium would require integrations with other frameworks for reporting and test running, and then you'd need to integrate it with other services after that, which can be quite a headache. As well as that, it's one of the latest APIs on the market. Competitors are Cypress, Selenium, Puppeteer, and others. And the benefits of it is that it executes much faster than the Selenium framework. It supports multiple browsers, which Cypress cannot do. And it allows API testing as well, which other frameworks are unable to do. This also makes it one of the better frameworks out there at the moment, as it's an all-in-one package for automated testing. Now on to Cucumber. So Cucumber is a business-driven development tool, and this is used to create readable specifications in plain text. This makes it useful when dealing with stakeholders, such as business analysts and product owners, who can directly input what they want into the tests themselves. Each specification consists of scenarios, and each of these is a list of steps. The steps follow a rule of given a situation, when a condition occurs, then executes an action. The action is normally a comparison action or verifying that data is on the page and it's what we expect to see. Basic syntax rules called Gherkin syntax also apply to Cucumber, and you'll see this in the example we have on the screen with our scenario. So given our situation, where the maker has chosen a word, when our condition, the breaker is made to guess, then our action, which is the maker scoring. Then we have TypeScript. This is a programming language that's developed from JavaScript, and it compiles back into JavaScript as well. It was developed to improve productivity when working on complex applications, and it allows the types of data to be passed and can report errors when types do not match. This is something that JavaScript does not do. It was developed for front-end applications and has been used for development frameworks such as React and Angular, Angular being built entirely on TypeScript, so it's quite popular for the web. Its benefits are, it's useful when multiple developers are working on a complex project. This is because JavaScript parameters and variables don't contain information, but in TypeScript they do. This allows for type errors, and that helps debugging and reducing complexity when working with other teams. It's an object-oriented language, and it's based on objects which contain data and code, and programs designed by making programs out of objects which interact with each other. JavaScript is a prototype-oriented language where inheritance is performed by reusing existing objects that serve as prototypes. Like I said before, it does compile back into plain JavaScript. However, the features it offers has made TypeScript incredibly popular on the web. Now on to user journeys. So a user journey is the path a person follows as they discover a product, service, or brand and learn more about it, and then make decisions around purchasing or not. It's something that comes up in UX, UI design, marketing, and testing. The reason testers use it is because it gives us paths with the most amount of footfall or interaction from a user. And these are the paths where we want to test the most to make sure that they'll have the correct functionality because they'll be used the most. They are a fundamental part of testing. You don't generally need to know them, but it does make your life a lot easier if you do know them. And generally, you want to test by following the common user journeys as well as some edge cases and uncommon ones. These include things like creating an account, making a purchase, inputting data, or extracting information. Now onto the page object model. The page object model is a concept that originally came from Selenium. By creating an object repository for calling in web elements, you can reduce code duplication and make maintenance easier. In the page object model, each page of an application is a class file, which contains the web elements for that page, and then that can be imported into our step definitions. Please note, in the demo, we don't actually use one page objects per page. This is because the user journeys we have are quite short, so we've just put everything into one page just to make it easier. Also, in larger projects, you'll want to put everything one page to one page objects because it makes things much less confusing, as I learnt in my early days. The advantages of the page object model include allowing easy maintenance, meaning you can quickly find what you want to edit and then make that edit. Code reusability, meaning you can write once and use anywhere. Readability and the reliability of scripts, meaning that the scripts are easy to follow and understand, particularly if you're introducing somebody new to your project. And the scalability of scripts, meaning you can increase the amount without creating too much complexity. Now, for the page object model, there are some best practices. The single responsibility principle. Each page object is responsible for a single page. Abstraction. Page object should abstract the details of interacting with the page, such as locators. Encapsulation. Page object should encapsulate the state and behavior of the page, make it easy to understand what the page is doing. So rather than having UI ID 12, you can call something the login button, for example. Reusability. So page objects should be reusable across different tests. Easy to understand, so the naming of methods and page objects should be self-explanatory. This helps with debugging and also introducing others to your code. And then the separation of concerns. The code should focus on the high-level behavior of the page, while the page objects focus on the low-level behavior. Then, when working with automation testing generally, there are some best practices. So you want to automate tests that are difficult for people to complete, that are repetitive or time-consuming. You want to select the right tools. So normally you want a test suite that matches the tools you're testing. So for an example, if you're testing an application written in TypeScript, you want your testing library to be written in TypeScript, just for consistency and ease of use. You want to create tests that are resistant to changes in the application under test. So in our lab, I'll show you how we use some test IDs, just to make sure we select the right elements, and how other elements are quite breakable. And then you want to create a test environment where possible. So this is an environment where you can break things without affecting users or causing data corruption or downtime. And you want to use quality test data. So you want to use test data that is similar to production data, as similar to production data as possible. And now on to the demo. So if I just end that there. And we have our lab here. So you want to go on to lab.devopsplayground.org. That's if you want to follow along. And then you can just type in your meetup username here. And it will give you the username, password, and the other links that you'll need. Let us know if you need any help with that. Yeah, sure. In fact, I'll just put it onto here. So yeah, this is the link you'll need. And then once you're there, you can just type in your meetup username. Now what I'll do now is start the demo. So we have our terminal, we have our README. Sorry, we have the README here, and we have our code here. So I'll begin with a short introduction. In fact, let me go to the README first. Begin with a short introduction. I'll go through some outcomes for this demo, where to go for questions, and then we can set up the framework. So modern applications need to be thoroughly tested before they're released. This is either due to compliance with the law, or to avoid distress to users, or for safety. The template today will introduce you to the integration between Playwright, Cucumber, and TypeScript. For this example, I've used 3 practice sites. So there's one from softwaretestingboard.com, another from a company called Global SQA, and another from Source Labs. The outcomes that we're looking for today are to understand the structure of a Playwright, Cucumber, and TypeScript project, understand how to write tests with the page object model, understand how to format and write automation tests utilizing Playwright and Cucumber in TypeScript. And then if you have any questions in the room, just raise your hand and then our guys will come and help you. And on the call, there is the DevOps Playground Slack channel for you to use. So let me just, So what we'll do first is we'll want to copy. In fact, I'll use the little button over here. That's the best way to copy, just to make sure you don't miss anything. And then going into our project. In fact, let me go through the file structure first. That'll probably make it easier. So the main files we're going to be using today is the cucumber.js and package.json to set up. Then in our source and test folders, we've got a feature files folder, and that's where our feature file is going to be. We have our pages folder, and that's where our page objects are going to be. And then we have our step definitions, and that's where our step definitions are going to be. Oh, do you want it bigger? Yeah, no worries. I think. And is that okay? Awesome. So yeah, feature files with our feature files, pages with our page objects, step definitions with our step definitions. So to begin, I'm going to go into the package.json in the root, and I'm just going to paste in the contents of that file. And that file was taken from here in the README. So that's done, we can save that. And then going into our terminal, I've already gone into this one, but what you want to do is, in fact, let me go out and then I can show you. So we have our working directory, so just cd into that. Then we have our Playwright Cucumber framework folder, and we can just cd into that. And then you're in our root directory. So from here, we can run an npm install, and that will just install the things we've put. Sorry, is this big enough for everyone in the room? No? Okay. Let me see if I can. Is that better or a bit bigger? Cool. Thank you. So yeah, we're just going to run npm install for that one, and that will install our dependencies. Now, while that's running, just go back to our package.json. So we have name, version, description, and main. Those are fairly standard. Scripts, keywords, author, and license, you can ignore those. And then we have our dependencies. So if one for Cucumber, one for Playwright, we have types for Cucumber and types for Node, and then we have TS Node here. Then we've got dependencies directly for Cucumber and TypeScript. So run npm install, and that should be finished now. Yep. And what we'll need to do next, let me make this bigger as well. Is that big enough for everyone in the room? Yeah, cool. And then what we'll want to do next is run npx playwright install. So we'll copy that, then going back to our terminal, we'll just run that here. And what this is doing is just downloading our WebKit, and that controls the browser for us. So give that a second to load. And I do believe we have an error. Missing dependencies.
It was giving an error further up saying that because we're on Amazon Linux, it's not officially supported.
Yeah, we can ignore that one. When we ran through it earlier, it worked even with that warning. But yeah, no, that's not a fatal warning, that's fine. Just looking here, Playwright core. Give me a moment. So what I'm just going to do is go back to the README. That should be fine. Do wonder. Just going to run npm install again, see if that helps. And then the same error. Yeah. Yeah. On the npm file, yeah. Sorry, just for reference, this didn't come up in our dry run, this error, so we're just working that one out.
So, yeah, that's because on this part that you're running now, you're supposed to run it after you fill out everything. Remember, that's why it works in the complete one.
Yeah.
So step by step. So if you fill out everything, this will work.
Okay.
But right now,
Yeah.
just carry on.
Maybe ignore it.
Okay.
I just went on to run the Cucumber and it just
Okay.
run. So
Yeah.
maybe
Let me try that then. Yeah, thank you. Yeah. So what I'm going to do, so what we can do here, I'm just going to continue and see what happens. So next I'm going to copy this and then I'm going to go to our cucumber.js file and then just paste that in. Now this is the glue file between our feature files and our step definitions. So this is the path for our feature files. This is the path for our step definitions. You can ignore the require module. These are our reporters. So you have the JSON report, that's good for pipelines and integrating that with CI/CD. And I found the HTML reporter is good for showing stakeholders. The summary is just the summary we'll have in the console, and the progress bar is what we'll also have in the console. Since we're running this headlessly, it just makes life a bit easier. Format and export you can ignore. So if we go back to the README and we just copy the command npx cucumber-js and then just paste that in. And yeah, no, that is working. So at the moment we've got 0 scenarios, 0 steps, and 0 seconds to, well, 0.01 seconds to run. So that's all good. So now we can start filling in our tests. So if I go back to the README. So creating automation tests, there are 3 layers we're going to be working with the page object model. The first is going to be the page level, and here we can list our IDs in one place and they can just be called upon as and when by the tests. Sorry, is this big enough for everyone? No? Okay. There, I'll just zoom in a bit more. Better? Cool. This is all in the README on your laptops as well, if you want to follow along with that bit. Equally, the screen's also fine. So we're listing our IDs in one place, and these are going to be in the pages folder, and they're going to be called the login page, the global SQA page, and the source page. The actual requests themselves are going to occur in the step definitions, and the Cucumber instructions will occur in the feature files. So step definitions just define the steps that we put into our feature files, and then the feature file itself is where we put our direct scenarios and our data input. Again, Cucumber supports behaviour driven development, and central to that is Gherkin, which is the language we're going to be writing in. It's good for stakeholders, and it allows expected software behaviours to be specified in a logical way that can go to straight to customers, essentially. So when you have non-technical people, giving them a Cucumber file or a Gherkin file is a good way to break the walls down between the complexity of the code and what's actually going on and what the actual outcomes you're expecting are. Now, in many cases, these scenarios require mock data to exercise a feature. That's going to be quite cumbersome to inject manually, and also through automation tests. And when you've got complex entries or multiple entries, it can be an absolute nightmare. With Cucumber, we can mock this data using data tables, which I'll show you shortly. And this will pass data directly from a feature file into the step definitions. And from there, it can directly inject it into the application. And that's also incredibly useful if you have specific things that the stakeholder wants to put in, and you can just put them directly in and everyone's happy. So first, we're going to add the feature file. One thing to note, you do need to put your own values into here. And another thing to note, and I'll go through that shortly, another thing to note is that the passwords are here in plain text. Generally, you don't want to do this. It's kind of a bad idea. But what you can do to mitigate it is use environment variables. You can use configuration files. You can store the passwords elsewhere and bring them in. Or you can encrypt them directly, bring in the encryption, then decrypt it on the other end. That's not in scope for this presentation today, so that's why they're in plain text. So what we're going to do is just copy this, go back to our code, go into our userjourney.feature in our feature_files folder, and then I'm just going to paste that in on line 4. Now, this first website needs to have, sorry, is that big enough? Yeah, cool. The first website we're using needs to have a unique email. So we're just going to do that now. So and the first name and last name we're going to make unique as well, just so we can, in the then step, verify that they're there. So for me, my machine is called Funny Panda, so I'm just going to do that. Do Funny Panda at test.com. And I'm just going to do tests just to make it particularly unique. And then save that. Unfortunately, there's no auto formatting on here, so it's not particularly neat in the data table, but when you format it in Visual Code, if you have the extension, if you have the setting for it, then it'll just format on the save, or you can just, I believe the command's Control-Shift-K, and you can just format it that way. But that'll make everything neat and tidy for you. So we have that. So we have, given the home page is displayed, when the user enters their account information and creates an account, then the user should be logged into the site. Now what I'm going to do, I'm going to go through that in front of you visually, just so you can see what's happening. So this is the website. This is from softwaretestingboard.com. So we're going to click on this create an account first. I'm going to put A, B, and then test.com. Password is the same one we put in the file. then we're going to create an account. And ignore that. And then we're just verifying this contact information in the then step. So if I go back, so what we're going to do is go to the README, and we're going to copy our given step. And we're going to go into userjourney.steps.ts. And on line 13, I'm just going to paste that in. So what we're doing here is we have our given, the home page is displayed. The reason I put this timeout in here is because there is one disadvantage that I've found with using Playwright and Cucumber together, and that is you can't set a global timeout. I tried several different methods of doing it, and each time it just defaulted back to the 5,000 milliseconds option. So when I put the timeout into the step definition directly, then it worked. So this is a 10-second timeout rather than the 5-second one. I don't know why that is. I've contacted Cucumber and Playwright, and I'm just in conversation with them about the issue and seeing if they can fix it.
5,000 is 5 seconds?
Sorry?
5,000 is 5 seconds?
Yeah, so it's 5,000 milliseconds, which equals 5 seconds. In here, I'm doing 2 times 5,000, so that's 10 seconds. Yeah. What we're doing, we're creating a new browser, and we're running it headlessly. Unfortunately, the infrastructure we've created can't run it non-headlessly, so that has to be run headlessly. We're creating a new context and creating a new page, and then we're just going to the website page there. Now, if we go back to our README and copy the next step definition, and this is where we're defining the values from our data table. Don't worry about the errors for now, we'll fix those when we put the page object in. So what we have here is where, so if I go back to the user journey, also I'm just going to close package.json, cucumber.js, we won't need those anymore. You can see we've got this information here. And this is injected in the form of a data table, which is being passed through here. We're creating a new login page, and that's from our page object. We've got a table hash of the rows of the data table, and then we have a hash of that. We're clicking the click create count button. That was on the home page there. And then once we're in, we're clicking on the field we want to fill, just to make sure we don't actually type this, or sorry, accidentally type this stuff into a search bar or something. Then we're just filling that with the first value from the row, and then second, third, fourth, etc. And then finally, we're creating an account. So if I go back to my README and scroll down, and then we have our then step. So if I just copy that, and then on line 49 of our userjourney.steps.ts, I'm just pasting that in. What we're doing here, we're expecting our account name to be visible, and we're just closing the browser once we're done. So those are the step definitions, the 3 step definitions for our 3 steps here. Next, if we go back to the README, we have our page objects. And this will be in loginpage.ts in the pages folder. Now you can just highlight from lines 1 to 9 and just paste this over. Now what we're doing here, we're importing the page and locator from Playwright. We're defining our locators here, and then we're filling in the values in our constructor. You can see we used a variety of things. We're getting by text. That's generally not always recommended, since when the web page changes, that might break. We're getting by IDs, which is preferably what you really want to do where possible, because if something changes on the page, that won't break. We're getting by role, so we're getting a button here. This value on line 31 we're going to need to change, and what we're going to change that to is the user, so the first name and the last name we had in our userjourney.feature. So I've put in funny panda in both lowercase, so just fill that in there. Then here we have an XPath. Now, as you can see, it's HTML body, div, header, div, lists, and a link. Generally, you don't want to use this because if any one of those values changes, the test will break. Unfortunately, I can't control the site, the softwaretestingboard.com site, and this was the only selector I could find that worked. So this is why I've used it. Preferably, you don't want to do this where possible. And if you have the ability or a good relationship with the developer, or you have access to the code base, generally just put in your own ID. It just makes life so much easier. And we have some more IDs here. And then we have some methods that's just abstracting the interactions on the page.
Absolutely expert.
Sorry?
Is that absolutely expert? Is that absolute expert?
Oh, no, not at all. It's completely not absolute. It's if anything changes on the web page, that XPath will break immediately, and you have to go in and re-find it and refill it in and all that. You do sometimes have to use it, though. There are times where you can't get hold of the element any other way, and yeah, you just have to use it. But it's something to be wary of. So now if we go back into our user journey.steps, you can see the errors have gone, and we're ready to run our test. So if we go back to the terminal, and once again we run npx cucumber-js, and this should run our first test for us. So you can see the progress bar there, and it should give us a summary momentarily. And we have an error. So, funny panda. So yeah, it was looking for funny panda on the page and it couldn't find it. So, and it's also timed out 5,000 milliseconds. So if we go back to our code, and if we go back to userjourney.steps.ts, it appears our timeout wasn't working, which is interesting because that was working earlier. We have the account name. What it might be, and this sometimes happens, particularly when you're running this for the first time on the machine, is that the page takes a while to load up. So if this timeout of 10 seconds had worked, then it's entirely possible the test would have passed. So what I'm going to do is close that, and I'm just going to run it again. And what this might do is if it's running, if it's cached, then it should fix the error. And it hasn't. Interesting. Timed out. Let me try with a new email, because it might be because the email needs to be different each time. So if I go to login page here, just double checking that we have our name here that's correct. And that is the same as our user journey here, that's fine. And then just fill that out, save that again, and run it a third time. Again, this is why the loading bar and the summary on here is quite useful, because you can see what's going on. That's failed again. That's fine. I'm just going to close that off. What I will do as well, I'll show you this locally, and I will run that non-headlessly so you can actually see what the browser is doing, and it also might pass. So let's go through that now. So if I go here, just make sure that's unique. If we go to our user journey.steps here, and our login page here, just making sure the name is correct. Make that fill the screen, and run npx. And then you should be able to see that one. This should, there we go, create a browser for us. So you can see it's going onto the site, it's creating an account, and it's finishing. And that one passed. I'm not sure what's happening on the lab, but that's fine. We can just ignore that for now. But that's, as you can see, firstly, that was much faster than a human would be. And secondly, it's fairly consistent. So if I ran that again, it would do exactly the same thing. So that's that. So if we go back to our code here, next, we're going to write the next test. So go back to our README. We have our second scenario. So if I just copy that, go back to our userjourney.feature. So what we have now, we have the global SQA site. So given the home page is displayed and the user signs in, when the user is making a deposit of £12, then the user should see their transaction. So I'm just going to go through this visually for you. So this is the site. So we're clicking on the customer login button, filling in a character name. We're logging in here. We're depositing an amount, so 12, depositing that, successful. And then on here, you can see the amounts here, and we're just verifying that number there. So on here, if we just go back to our README, and we're copying our given step. And again, on here, we're literally doing the same thing that I just showed you. So if we go into our userjourney.steps, and then on line 54, we're just pasting in our given step. So again, we have this timeout. We're running it headlessly, creating a new browser with a new context, and then we're going to the first page. So if we go back to here, and we copy our when step, and we can just paste that in on line 62. Again, don't worry about the errors, they're going to be fixed by the page object. So we're getting a new page from the page object here. From the page object, we're getting the login button clicking, the drop down clicking, getting the value of 2, and then just clicking through there. If we go back to our README again, and we can just copy this extra when step. So this is something else to note about the Gherkin syntax. So if we go to our user journey, you can see there's an and step here. But in our userjourney.steps, this converts to a when. The reason for this is there isn't an and step in the step definitions. You can just put a when step in instead, and it resolves to the same thing. So we have that there, and you can see we're passing in a string this time as well. So that would be this 12 here. And you can also pass in floats, numbers, integers, any values really. So passing in that string, and then we're just filling using that string. That's a much simpler way to input information rather than a straight data table. So we have a deposit there, and then we have our then step. And we just put that in on line 78. And what we're doing again, we're just clicking the transaction button and verifying the transaction. And then our extra and step. Again, this resolves to a when in the step definition, but if you look in the file, user logs out. Oh, sorry, that's from another thing. Don't worry about that. So from our feature, we have given and when then. So if we go back to our file here, we can copy the page object. So if we go to global SQA page.ts, just copy from lines 1 to 9 and just fill that. You can see we are declaring our locators, and then we're just filling in the values for that inside the constructor. We have, again, get by text, get by locator, get by role, get by XPath as well. Again, I had to use this one. There wasn't an ID available for it. You can see we're doing a lot of buttons, and we're getting a lot of those buttons by the roles. And then we're getting by text number 12, and then we're logging out. So if we go back to our user journey.steps, you'll see that all the errors have gone now. And then if we go back to our terminal, in fact, before we do that, if we go to our user journey.feature, we're just going to comment out this test. Because the email needs to be unique each time, it will fail when we try and run it again. So rather than go through that, if we just comment it out for now, it just makes life a bit easier. So we have that there, and we have our page object sorted. So if we go to the terminal now, and then we can run npx cucumber-js again to run the test. And just give that a moment to load up. And that passed. So if I just show you visually this one as well. So if I go to my user journey.readme and get rid of that. So I just comment out this one and uncomment this one and save that. And then we can just run. So npx cucumber-js. And this should open a browser for us. And that's complete. So that's the test done. And passed. So that's our second test. And moving on, we have our third test. So back to the user journey.feature, back to the README, and this time we're using the source labs page. So on line 17, I'm just pasting in our scenario. Again, the password's in plain text, and again, you'll want to use environment variables, config files, and anything other than plain text to store that. You can also see we've got an and step after every step. So if I go back to the README now and take our given step, and we can put that into our user journey.steps.ts on line 83. And it's the same as before. We're creating a new browser headlessly, creating a new context, new page, and then we're going to the home page of the site. Now if we go back to our README, we have the and step. And then we can just paste that in underneath. Again, we're using a data table. So we're calling our page object. We've got a table hash of the data table rows, and then we have a hash of that hash, and then we're just filling that in. First clicking on the box we want to fill in, just to make sure that we're not filling in a different part of the screen. Then, what we can do is copy our next step. This is our when step. And we can paste that into line 106. And you can see we're just clicking each of the things. So adding an item to the bag, going to the shopping cart, and then checking out, or rather clicking on the checkout button. Going back to here, we can copy another and step. And this is just filling out the shipping information. Again, this would be from here. So it's these three pieces of information. And again, we're using a data table to do that. And then we have our then step. I'm pasting that in. And we're just expecting an order confirmation at this point. And our and step. And that's pasted in at line 134. And we're clicking the back to products link, or back to products button, I should say. And then we're just closing the browser. And then we have our page object, which will fix all of these errors for us. This will be in sourcepage.ts in the pages folder. And again, you can just copy and paste everything over. Again, we're declaring our selectors, defining them. And this site, thankfully, has IDs everywhere. So out of the three sites, if you are going to test something or check something, this is the one I recommend just for ease of use. We're also abstracting some of the logging clicking here. And then if I go back to our README, I do believe that's everything. So save that, go into our user journey and see the errors have gone. And information is present and correct. So if I go back to our fact, I'm going to comment out this test as well. We could run it anyway, it's totally optional, but just for ease of use at the minute. Close that, and then, not now, and then npx cucumber-js to run our tests. And give that a moment to set up, and that's done. So, if I show you that visually, so if I go to user journey, so I can comment out that, comment in this one, and just run, then we should see this running very fast indeed. So, just to show you what happened there, I'll go on to the lab here. So this is the home page of the source demo. So we have username and password. What we did, we added an item to the bag, we went to the cart, we clicked checkout, and we just filled in that information there, click continue, clicked finish, and then click back home. That test ran that in about a second or so, or well, less than 5 seconds certainly. So it really shows how, when you have a responsive application, how much faster the tests genuinely can be. But that's everything, and there is one more thing I can show you here, and that's the HTML report. So if I just reveal that in Finder, and just open this for you, then you can see this is the kind of report that's generated. And again, this is useful for sharing with stakeholders because it's a very visual representation of what's been going on. And I've never seen anyone who isn't happy with it. So you can see the pass rate here, when it was run, the duration, and other information here. And then you have the tests themselves with the information you inputted here. Just to go back to here, then you have our JSON report. And again, this is the one that you'll want to feed into pipelines when you're doing CI/CD. But with that, that concludes everything. So that's the end of the demo. Thank you for your time. And does anyone have any questions? Yep. Sorry, there's a microphone coming up behind you.
Test. Hello.
Okay.
So I've seen this thing with Selenium, where you can use IPython, interactive Python, to code your scripts for tests. Can you do something like this with Playwright and JavaScript?
Yeah, so I believe there's, I haven't used it for this one, but there's CodeGen that you can use with Playwright, and that will help write the scripts for you, well, with you. So yes, that is possible.
Yeah, and you can also include these scripts into Jupyter notebooks.
Yeah.
Yeah. Is there any similar solution?
I'm afraid I've not used Jupyter Notebooks, so I couldn't be able to make the comparison. But I'm assuming if it exists in Python, there's probably an equivalent you'll be able to find for Playwright.
Okay, that's it. Thank you.
Thank you. Any other questions?
In terms of the best practice, is it better to have a lot of and steps going into these, or to basically split it up into multiple different
tests?
Cucumbers? Would you say that's always the best case, or is there like a small limit of maybe one or two and is okay, but then you kind of cut down afterwards, or? I
would say so the general structure is given when then. If you have an and for each of those, that's fine. If you have any more than that, you can do it. I have actually worked on a framework where the person that was there before me had given when, then. It works. It's an it's a bit of a headache just to like work through it all. And it kind of breaks the principle of wanting your tests to be as clean as possible. So I'd recommend breaking it up into different smaller tests. But yeah, no, you can do it. I wouldn't recommend it though.
Okay, thank you.
Thank you.
Any online questions?
I guess I'd just be interested in maintainability of this once the test files start to get quite large. Like say you have like a bunch of people working on this, contributing a lot to it. Does it get a little bit like finicky once you get like say like a few thousand tests and then suddenly you have like quite long files and things like that? Like what are the best practices to maintain that or avoid bad situations at that point?
So one of the things you should do, which we didn't do in this example because the test was so short, was to have one page object per page. And then, for example, if you have a login page, you have a login page, checkout page, checkout page. That helps with the maintainability. As for the step definitions, you can also follow that through into the step definitions. So you can have a feature file for one page with step definitions for that feature file, and then a page object. So it's a sort of singular column of one test and all the definitions and the page objects behind that. That's probably the cleanest way to do it. But yes, it can get difficult sometimes. But I've been on projects with about 500 tests was the maximum we had. And by using the page object model and having that sort of column of A, B, C for each test, it helped just searching through it and trying to find stuff. So that's how I'd recommend doing it for larger frameworks.
And do you recommend that there's like a trade-off, or do you think there's a trade-off at some point where maybe like it doesn't make sense to use Cucumber anymore, or does it scale pretty well at that point? So Cucumber has a lot of readability, usability, which is incredibly useful for dealing with stakeholders, inputting information, and just having, like I said, the living documentation. You don't have to use Cucumber. I've generally found it easier for dealing with non-technical people, but when, for example, it's just you and a developer, even if the project's quite large at that point, working together with just Playwright on its own is totally fine. It just works well. So really it depends on the context of the project. So whether you'd want Cucumber to just almost get the stakeholders involved, the non-technical guys involved, or whether you want to just scrap that and have you and the developers like understanding, knowing what's going on. So yeah, it depends on context, essentially. I guess though, like, is there a benefit to scratching Cucumber? Like, will you code faster, basically, like if you don't have to put up with that, or is it beneficial to maintainability to like have that sort of stuff there? It
varies from person to person. So it is beneficial, absolutely, but it's not necessary. And if you feel it's adding too much complexity, or you don't want to maintain it, or it's more effort than it's worth, then you can scrap it. But again, it really depends on the context of the project. But generally, I'd recommend having it there, because if you're onboarding someone new, it's easier for them to understand what's going on, essentially. And even if you're a technical person, having those Cucumber files there, saying this is the outcome that we want, this is why we're doing this, is generally really helpful. Cool. In that case, I believe it's time for pizza.
No, hold on. So if there are no more questions.
So, one here.
Okay.
Oh yeah, sorry.
Yeah, I'm just wondering the use cases, because I'm quite new to both Playwright and Cucumber.
Yeah, that's fine. So Playwright is useful for UI automation. It's faster than Selenium. It supports multiple browsers, unlike something like Cypress, and it does do API testing as well. I found it quite useful. It's maintained by Microsoft, that's got a lot of stuff behind it, that's got a lot of money, a lot of interest and intellect and work behind it. So I found that quite useful. Cucumber is, like I said before, good for dealing with stakeholders. So if you have non-technical people and they want to input data directly into your tests, they can do that easily. So that's the use cases really for both of them. And it's also usability, maintainability, all that good stuff.
Sure, I'll just give you a quick example of what I'm getting at.
Okay.
So for example, I work with insurance, so we're looking at like what our competitors are doing. So we use Selenium to like scrape different websites to gather price information. Could this Playwright be used for something similar?
Yeah,
in conjunction with Cucumber?
Yeah, you can use it on its own to scrape websites. You can use it with Cucumber to scrape websites. Yeah, no, absolutely. That's one of the reasons it's there.
Yep, told you you'd be quick.
Yeah, awesome.
One more.
Yeah, go ahead.
Is there an alternative to Selenoid?
Selenium.
No, there's a thing to deploy it on the Kubernetes and to run it in containers.
Oh, I don't know actually. But what I can do, I can find out and get back to you if that's okay.
And can you connect to the web drivers remotely?
From where, sorry?
With Cucumber and...
No, so Playwright is in charge of the web drivers. So that's, yeah, that's down to Playwright. So Cucumber is just something that sits on top.
Sorry, Playwright, yeah.
Yeah. Yeah, no, that controls the web drivers.
Remotely? So
Sorry.
For example, there's the web driver running on the different server, and can you execute it remotely?
Oh, remotely, yes,
Yeah,
yes, you
okay.
can. Yeah, no, absolutely. Yeah, sorry.
We can use this BDD Cucumber in API testing.
Yeah, you can do. Yeah, I've done that before.
What is the difference between BDD and FTD?
FTD,
framework?
sorry.
Yeah. As earlier it was used that one. Do you have any idea on that?
Sorry, can you say again?
FTD framework. BDD is a behavioral, that is a framework, the Cucumber framework.
Yeah.
And FTD also, that one is also early that was used in some companies.
Okay. Generally, I've used business-driven development, so BDD, and test-driven development, TDD.
Nowadays
I've not
they are
used FTDD before.
Okay. Nowadays they are using BDD. Cucumber framework they are using now, but early days they are used the FTD.
Okay.
Yeah.
No, I'll look into that. Thank you. Okay. Yep. Yep. No, I'm all done. So yeah, thank you for your time, everyone. It's appreciated.
All right. Thank you, Matt. That was great.